Today's lesson we are going to review simplifying radicals. And when you simplify a number, you're really being asked to make the number as small as possible or as simple as possible. Small is probably the best way to describe it. Now this one does simplify in the sense that if you take a calculator and take the square root of the radical of 25 and you click enter, it's going to give you a whole number. So radical 25 simplifies to this. And that's because 25 is a perfect square. 25 can be written as 5 times 5 or 5 to the second power. So the radical actually cancels out the second power and gives you the 5. 25 is not the only perfect square. We can actually make a list of perfect square numbers. 1 times 1 is a perfect square. Sorry, 1 is a perfect square because 1 times 1 gives me 1. 4 is a perfect square because 2 times 2 is 4. I can also write it as 2 to the second power. Or 3 to the second power, or 3 times 3. That means 9 is a perfect square. 4 to the second power, or 4 times 4, is 16. 16 is a perfect square. 5 to the second power, or 5 times 5, is 25 is a perfect square. 6 to the second power, or 6 times 6, or 36 is a perfect square. So you don't really have to memorize the list of perfect squares. You can just make your own list by taking a number and squaring it. Hence why it's called a perfect square. I can also represent these perfect squares as actual geometric squares. 4, for example, represents the area where the sides are size 2. 2 times 2 is 4. Similarly, for example, 25. I can represent 25 as a perfect square. 25 would represent the area of a square where the sides are 5 units long each. 5 times 5 is 25. So oftentimes sometimes kids, when they take an exam, they get really, they get brain block and they're like, I don't remember my list of perfect squares. Well, you can very quickly just create it by taking a number and taking it to the second power or multiplying it by itself, like 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. And so for problems like these, I'm going to actually keep this list to the side because it's going to come in handy. So the great thing about any perfect square, if we have to take the square root of a perfect square, like 100 is a perfect square, then it can be simplified into a whole number. And I plug this into the calculator, I'm going to get 10. And that's because 100 is 10 to the second power, excuse me. And the radical cancels out the power of 2, so the square root of a perfect square is its root. But what happens if we get a number that is not a perfect square? So for example, 5. Notice my list here. 5 is not a perfect square because there are no two numbers that multiply to each other, no two whole numbers that multiply to each other that give me 5. For example, 1 times 1 does not give me 5. 2 times 2 does not give me 5. That gives me 4. And then when I go to 3 times 3, that gives me 9. So there is no number. The only two numbers, the two whole numbers that multiply to 5 are 1 and 5, but they're not the same. Radical 5 cannot be simplified anymore. because 5 can only be created by the factors 1 times 5. But what if we have something like this? Radical 32. Now, if we were to plug in radical 32, we would get a irrational number because 32 is not a perfect square. Go on forever. So we can't write down a number that goes on forever. So the best way that we can do it is find two factors that multiply to 32 such that one of the factors is a perfect square that we can simplify into a whole number. So the best way, once you've created your list of perfect square, you divide. So 32 divided by 4, if I take 32 and I divide it by 4, using my calculator, I get 8. 4 is a perfect square, and then there's 8. Well, the goal is to get the biggest, to find what is the biggest perfect square that goes into the number, to find the simplest, in other words, the smallest. So let's go down the line. What is 32 divided by 9? So we know 4 goes into 32. So take 32 divided by 9, and if I do that, it gives me a irrational number that goes on forever. So that means 9 is not a factor of 32. You know it's a factor of 32 if the number goes into the number evenly. So let's try 32 divided by 16. It's going to give me 2. So another factor pair that multiply to 32 are 16 and 2, such that one of those factors has to be a perfect square. Now 25 is not going to go into 32 even, because 25 goes up by 25s. And 36 is bigger than 32, so we can stop there. Now notice that both of them can be used to simplify, but you want to pick the factor pair that has the largest of the two perfect squares, because that will give you the simplest radical form. So we're going to go ahead and just replace the top part by 16 and 2. Okay, so that's step 1. Find two numbers that multiply to the number you're trying to simplify such that one of them is the largest of the perfect square that can go into it evenly. Okay, better. Sorry about that. So then once we're there, then we can plug it in. We can then split the radical. If 32 is equal to 16 times 2, then the square root of 32 is equal to the square root of 16 times the square root of 2. Now because this is a perfect square, that will simplify to a whole number. Square root of 16 is 4. 2 is not in the list of perfect squares. If we were to put this in the calculator, we would get an irrational number that goes on forever, that we can't actually put down in the paper. It would be like 1.41 ... So if it can't simplify more, so if this number is not a perfect square, then you just leave it in its radical form. So this is the simplest way that radical 32 can be simplified. Let's practice another one. I'm going to list it. Okay. Now, what is 72 expressed in simplest form? Okay. So, first let's find two numbers that multiply to 72, because if I take radical 72 it's going to give me an irrational number. It's not going to give me a lovely whole number, which tells me 72 is not a perfect square. So we start by going down the line. So if we take 72, let's divide 72 by 4, see if it gives us a whole number. If it does, 4 is a factor of 72, and it gives us 18. So 4 times 18, so 4 works. But let's not stop there. Let's keep going. What about, because we're trying to find the largest of the perfect square that goes into 72 evenly. What about 9? If I take 72, I divide it by 9, I get 8. So 9 times 8. Let's keep going. 72 divided by 16. I'm just going down the line right here. So this goes 72 divided by 16 gives me 4.5. So nope, it's not. 16 is not a factor of 72. 25 is not. You know, it should either, in order for a number to be a multiple of a number, it has to, like 25, it has to either end in 0 or in 5. So I'm not even going to bother dividing 72 by 25. But what about 36? 72 divided by 36, and it gives me 2. Ooh, so yes, 36 is a factor of 72 because it goes in evenly 2 times. 32 times 2. Now if I were to continue going down the line, I'll find that I'm not going to find any perfect square that goes into 72 evenly. Like at some point, like we'll have 49, then we have 64, and then we also have 81. So notice that by the time we get to here, we can definitely stop because 81 is bigger than 72, so it could never be a factor of 72. So now that we kind of went down the line and found the biggest perfect square that goes into 72, that's the factor pair that we're going to choose. If I had chosen 4 and 18, 9 and 8, I would be able to simplify this further, but it's requesting the simplest, so neither of these would have been correct because they wouldn't give you the simplest answer. So we're going to go ahead and rewrite step 1. I should say 36, sorry. 36 times 2 gives me my 72. That's definitely larger than 9 and 4. So now I can rewrite square root of 72 is equal to the square root of 36 times the square root of 2. Why? Because 72 is equal to 36 times 2. And now we could say that the square root of 72 in its simplest form, the square root of any perfect square will give you a whole number. If you plug that into the calculator, it's going to get 6. And then this 2 is not a perfect square, so it just stays in the radical. Now let's introduce a slightly more, I wouldn't say complicated, I don't like that word. It just means it's an extra step, doesn't mean it's complicated. And so on. What if we have a number outside, for example 7 radical 90 or 7 square root 90. Now some kids see that and they freak out, but don't freak out. That just means that you have one extra step. That just means, when you don't see a sign between the coefficient in front of the square root of 90, there's an invisible multiplication. So just keep that in mind. Step 1 is still the same. We're going to find 2 two factors of 90 in this case, the number inside the square root, that go into 90 such that that one of the factors is the largest of the perfect square. So we can just go down the line. 90 divided by 4, that gives me 22.5. So it's not a whole number, so 4 is not a perfect square. Okay, 90 divided by 9 gives me 10, a whole number, so 9 is a factor. Now I could keep going, but one thing that's telling me that that's going to be the largest. 9 is going to be the largest of the perfect squares that goes into 90, because 10 is really just 5 times 2, right? And 5 is not a perfect square, and neither is 2. So this is definitely the only factor pair with the only perfect square that goes into 90. But you could keep going on the line. 90 divided by 16 is not going to give you a whole number. 90 divided by 25 is not going to give you a whole number. 90 divided by 36 is not, and so on. So this is the pair that we're going to use. So we're going to rewrite the problem as it was, including with the 7. And just to make things a little bit more clear, actually, I'm going to put the invisible multiplication sign that we don't see in the original problem. It just says 7 radical 90, 7 square root of 90, right? There's an invisible multiplication sign right there. Okay. There's a little leg there. Okay. So what's in the right side is going to equal the left side. The 7 doesn't go away, but now the radical 90 gets split into 9 times 10. Radical 9 times radical 10. I could probably make this a different color just to keep it a little bit. So not that different from what we did earlier. Okay, that doesn't go away. 7 radical 90s is equal to 7 radical 9 times radical 10. Why? Because 9 times 10 is equal to 90. Now this is the perfect square, and any square root of any perfect square is going to give me a whole number. Put that in the calculator. It's going to give me 3. Radical 10 in the calculator is going to give you a big long irrational number, so we can't simplify it without the radical stays. 7 times 3 is 21. Radical 10. So notice the 7 didn't go away. Okay, it just means that at the end I'm multiplying 7 to whatever that simplified version of the radical was. Let's do another example with a number outside of it. We're gonna do 5 radical 20. Okay, so step 1, we're gonna simplify. We're gonna find 2 factors of 20. And we go down the line starting with 4. 20 divided by 4 is 5, a whole number, so yes. 20 divided by 9 does not give me a whole number. 20 divided by 16 does not give me a whole number, and then we could stop there because now we're getting to numbers that are bigger than 20, so they can't be factors. So we've checked all the possible ones. So now we're going to rewrite the problem. I'm going to not forget that really there's invisible multiplication between the coefficient 5 and the square root of 20. 5 is the same, but then radical 20 gets replaced by radical 4 times radical 5. Why? Because 4 times 5 is equal to 20. So the 5 doesn't go away. We're writing an equivalent expression on the other side. Four is a perfect square, therefore the square root of 4 gives me a whole number. Radical 5 stays because 5 is not a perfect square. 5 times 2 is 10. Radical 5, 10 radical 5. So 5 radical 20 can be simplified to 10 radical 5. And one more example where we have a fraction. A fraction shouldn't scare anybody. You have radical 32 divided to 4. And we did 32 earlier, right? We start the same way. We find two factors that multiply to the number inside the radical, we call the radicand. And we want to make sure that we find two numbers that go into 32 evenly. Okay, and we found 16 and 2 earlier. As the biggest, we know 4 goes into it, 9 does not, but 16 does, 25 does not, and then 36 is bigger than 32, so we can stop there. 16 is the biggest. So in the same way, first step 2, we can rewrite the question. That's radical 32 divided by 4 is equal to an equivalent expression. 4 doesn't change, but radical 32 can be rewritten as radical 16 times radical 2 because of step 1. Now we can go ahead and simplify the radical of the square root, the radical of the perfect square. So radical 16 is 4. Radical 2 cannot simplify into a whole number, so it stays. And then we have the 4 underneath in the fraction. Now any number divided to itself turns into 1. But 1 times radical 2 is just radical 2, so they cancel each other out. Hope this helps.